see some hands. That's good. All right, welcome everybody. Good afternoon. I hope you're all well rested, hydrated, caffeinated. This is going to be a long talk. We are doing a technical tour for the Odoo Services applications. My name is Panagiotis Kyriakou. I'm a software developer at the Odoo Services team. And it's going to be a long one, so let's just jump right into the agenda for today. So we will begin with some introductory remarks. I want us to be all on the same page regarding the presentation's topics before we begin the presentation. And then we will continue by exploring the project app, then the Timesheets app. Then we're going to look into an example feature, which in this case will be the project profitability feature. Then we're going to go over the planning app, and then we're going to go over another example feature, which in this case is going to be the auto plan shift feature. Now, I was planning on doing a small intermission, but we were plagued with technical difficulties, and I don't think I will have the time. So we'll just have to kind of power through that. Okay, so what is this presentation about? I think it's kind of self-explanatory. It's a technical tour of the services applications. But I want this to be more of an introduction to that technical side of the services applications. What we're going to be doing is we're going to be looking how the applications are set up. And we're also going to be looking at these example features in more detail. So we're going to be focusing on code and seeing exactly how they work. I basically want this to be kind of a zero to hero type of presentation and get you up and to get people up and started in their Odoo development journey. So, who is this presentation for? Now, as I said, it's an introductory presentation, so a lot of the things that I'm going to be talking about are going to be introductory. So if you have a lot of experience with developing things in our applications, then it might get a little bit boring for you. Ideally, what you have an informatics, a computer science background, so you can read code because we're going to be looking at code. You can read some technical diagrams because we are going to be looking at some technical diagrams. And you don't have much experience with our applications, but you can have experience with other Odoo applications. So let's look at what part of the architecture we're going to be focusing on. So as you know, or as you can see, Odoo follows a three-tier architecture structure. We have the presentation tier, the logic tier, and the data tier. So in this presentation, we're going to be focusing in the logic tier, which basically it's the tier that we're doing logical operations or data that we have already fetched from the database. So we're not going to be looking at any JS code. If you're interested in that, talks about the JS framework. We're not going to be looking at any performance queries or the ORM framework because, again, it's kind of out of our scope, and there have been presentations on that. So we're only going to be focusing on the logic tier and our application specifically. So for everybody that doesn't know, the services applications are applications that are focusing on companies that offer services. So we have the project application, the Timesheet application, the planning application, the help desk, the to-do application, and the field service application. Now, unfortunately, in the interest of time, we're only going to be focusing on the first three applications, as you saw in the agenda. But yeah, these are all the applications that we are working on. So, what if you have questions? This is our second technical difficulty of the day. My QR codes are not working. So this is the link to the pad. You can just go to the regular pad.odoo.com and you can fill it up with Odoo _OXP _services _tech _tour. It's kind of given the title of the presentation, kind of makes sense. Now, if you have any questions, ask them in the pad. I have included a link to the presentation slides in the pad also, so if you're not able to see the slides properly because we're looking through code and some diagrams, you can zoom in from your phone and see things more clearly. Now, I will try to answer some of the questions in the end, but I think we might not have the time that we need, so I will try and answer the rest or all the questions after the presentations in the pad or tomorrow. Now, so let's begin with the project application. So if you don't know, the project application allows users to organize, plan, and track their projects and their project's tasks. So let's begin by looking at the database schema for this application. As you can see, it's a little complicated. It's an entity relation diagram, but we're going to kind of tackle this by taking each model and looking at each model one by one. Now, I'll warn you, it gets a little bit repetitive. It gets a little bit, but kind of boring, I suppose. But it's kind of important for you to understand how the application is set up. I'm sorry. So let's begin with the project.project model. So this model represents the projects of the application. It has typical fields or columns, if you want to think of it as tables, such as the name of the project or the description of the project. And it also has relational fields to other models or tables in the database, such as the collaborator's ID, the stage ID for the stages project, the update IDs for the project updates, the tag IDs, the type IDs, which is the tasks stages, the project tasks, and the milestone IDs, the milestones of the project. And now the next model is the project.collaborator model, which basically represents the collaborators of a project. It's basically a link up between partners and projects if partners have been given access rights to the project. So it has fields such as the partner ID, which points to records in the res.partner table. And it also has a field for the project ID. And it has also helper fields such as the partner email, which is again taken from the res.partner table. Then we have the project.milestone model. This is a model about the project milestones, which concern a subset of their tasks. Again, it has typical fields that we would expect, such as the name of the milestone or the milestone's deadline, and it also, of course, has relational fields to the project ID, pointing to the project record that it relates to, and the task ID is basically the tasks that are concerned about that milestone. Now, we have the project.project.stage model, which is basically a model that represents the project stages. They're similar to task stages. A project can be at a given stage at a given time. So it has fields such as the sequence, the name of the stage, whether the stage is folded or not in the Kanban view, and it also has the mail_template_ID field, which is a many-to-one pointing and the mail.template model. And that is mainly used for automations. When the project has reached a specific stage, we send out an automatic email. So next up, the project.update model. It basically represents status updates that you can get for your project. It has fields such as the name of the update, the status, the progress, etc. It has a project ID field, which points to the project that the update relates to, and it has also, status fields, kind of like the task count and the closed task count. Now, the project.tasks model, the tags model, is basically represents the tags that can be given to models and tasks. They have the name, and they have a color for visual purposes, and they also have relational fields that go to projects and tasks that are using these tags, basically. Now, lo and behold, the project.task model is very similar actually to the project.project model. It has, again, the task's name, the description, things along those lines. And again, it also has a lot of relational fields to other models in the database for the project application, such as the project ID, the project that the task belongs to, the milestone ID, the stage ID, the tag IDs, the recurrence ID, and the personal stage ID. We're going to look at these models right now. So the project.task.type model is basically the task stages. So again, it works similarly to the project.project.stage model. It has a name, it has a description, it could be folded or not in the Kanban view, so it has fields for that. And it also has a project IDs relational field that points to the project that have this stage in them. And it also has a mail template ID, as we saw with the project.project.stage model. But now it also has a rating template ID, which is very similar to the mail template ID, but is used for a feature where when a task reaches a stage, it can be an automatic email about ratings can be sent to the partner, to the customer, whatever it has been set up. Now, next, the project.task.stage.personal, they're getting quite long actually, is a model that represents personal stages that are specific to the user. Now, it has, of course, relational fields that point to the task ID and the stage ID because they're pointing to stages, and the user ID because they are personal to users. They're not shared between users, even in the same project. Finally, the project.task.recurrence model basically represents recurrence configurations that can be given to tasks. These recurrence configurations can be something like repeat this task every week, basically, if we want to get a new task that is similar to a previous one. So again, it has a relational field that points to the task IDs field that points to tasks that have this recurrence configuration, and it has fields of temporal nature such as the repeat interval, the repeat unit, repeat until some time, and it also has like selection fields such as the repeat type, basically whether we want to repeat for X amount of times or whether we want to repeat until a specific point in time. So the project application has a lot of features that are enabled when we have other applications enabled in our Odoo instance. This is what we call, this is achieved through bridge modules. And bridge modules basically are used to add features to already existing applications. Now, they can depend on multiple or a single base application, and is basically how we achieve interactivity between applications at Odoo. Now, the project app has a lot of bridge modules. Here are some examples. The project HR expense, which links the project application with the HR expense functionality that we have in the expenses application. The project account module, which links project and accounting. The project purchase module, which links the project application and the purchases application. The documents project module, which links documents and projects, and of course we have a lot more. Now, one very interesting bridge module is the sale project module, which basically links the sales application with the projects application. And what it allows is to generate projects and tasks automatically from sale orders, something that I guess is very important for service offering companies. So let's see how it works in more detail. And again, we have another database schema, but this time we have a lot of models that we have seen before. But now they have extra fields, and we have some models that we haven't seen before from the sales applications. But these are all also existing, and we just added fields to them. So let's start with the project.project model. So again, we had this model already. We've added 3 new fields. We've added a Boolean field for whether this project is billable or not. We've added a sale line ID and a sale order ID fields, which point either to the sale order line or the sale order, respectively, basically, that the project relates to. Then we have the project.task model. Again, an already existing model. We've added pretty much the same fields, but this time the allow billable comes from the project.project model. You can see the connection that goes around. And it's added there for convenience. Then we have the project.milestone model, which we add fields to it because we can use milestones when we're billing for things. And so again, it has the sale line ID, basically the sale order lines that it relates to, this milestone. But it also has the product unit of measurement relational field, which points to the product unit of measurement. And we also have the project partner ID, which is it's taken from project ID.partner ID from the project table, and this is also added for convenience. So there are things that are there for functionality and also things that are there for convenience, of course, which again is for functionality, but I believe you understand. Now, the sale.order model, we have added basically relational fields that point to either projects or tasks. Now, here we have 2 project fields. That is because we can, when offering a service product, that product can create either a project, which we can add tasks to, or it can create a task inside already existing project. So that is why we have this distinction between project IDs and project ID. Then the sale order line, it has pretty much the same fields. It has a relational field pointing to the project record that it relates to, a relational field that points to the task record that it relates to, and also the reached milestone IDs, which is basically the related milestone, project.milestone for the sale order line. Right, now that we have kind of we've seen how the project application is set up. We've seen how bridge modules work. We can move on to our next chapter, which in this case is the timesheets application, which again, if you're not familiar with the application, it lets users encode and track the time spent on different projects and tasks. And it's also fully integrated with the accounting module. It is dependent on actually on the accounting module. So this is the database schema. This time is much less daunting. It's much simpler. So let's dig in. We have the project.project model again, in which we have added fields such as the allocated hours, the total timesheet time, and Boolean fields such as the is project overtime. And we have also added relational field timesheet IDs that points to the timesheets that are related to this project. And we also have added timesheet encode UOM ID field, which points to the unit of measurement that we're encoding the timesheets in. Then we have the project.task model, which we have added pretty much the same fields. We have the allow timesheets Boolean model, total hours spent, the progress, and the overtime. And we also have a relational field timesheet IDs that points to timesheet records that relate to this specific task. Then we have the account.analytic.line model. As you can see from the diagram, we don't have a specific timesheets model because timesheets are actually account analytic lines with some extra features. So we have added some new fields to have these extra features in the account analytic line. And these are the project ID and the task ID, basically the project and the task that this timesheet relates to. We have the user and the employee ID, which is basically the user or the employee that has encoded this timesheet. And then we also have the encoding UOM ID, which is again a relational field pointing to a unit of measurement record, and is basically the unit of measurement that we're using to encode the timesheets. This can be hours, this can be days, things along those lines, depends on how you work. Finally, we have the project.update model. Of course, it makes sense to be there. We want timesheet information to be there in our project updates. So again, we have fields such as the display timesheet stats, Boolean fields, and we also have numeric fields such as the allocated time, the timesheet percentage, etc. And again, we have the UOM ID, which is the unit of measurement ID, that is pointing to a unit of measurement record in the UOM model. Now, as with the project application, the timesheet application also has a lot of modules, bridge modules that provide it with extra functionality. Here we have the sale timesheet module that links the sales applications with the timesheet application. We have the help desk timesheet module, which connects the help desk applications with the timesheet application. We have the timesheet grid module, which doesn't link to applications, actually just increases the amount of features that are in the timesheets app. And then we have the project timesheet holidays module, which links the timesheets application with the time off application. And of course, we have a lot more. So that was the timesheet application. I know that it has been a little bit repetitive, but at least now we know how these applications are set up, what the bridge modules look like, how they work. We can move on with our first practical example, the project profitability. Now, what is the project profitability, I hear you ask? And it's basically a section in the right side panel of the project update view. And it basically gives users a rundown of the project's financials, basically the costs and revenues that are relating to this project. So let's dig in. Let's see how this works. It all begins in the front end. We're not going to talk about it too much. We're just, there is this method in the front end, load data, that in line 6, as you can see, does an ORM call, a call from the front end to the back end, to the project.project model specifically, and calls the getPanelData method by also giving the project ID as one of the parameters. So let's look at the getPanelData method. I think this is more interesting. So the getPanelData method is this. We have omitted some details because they're not particularly interesting and they're not related to profitability. But in line 13, the profitability feature kind of starts. In line 13, we check whether we should show profitability by calling the show profitability function in the project.project model. Let's see how that works. Here you can see the two functions, one on the left, one on the right. So on the left, we have the base project modules function, the show profitability function. And as you can see, nothing's really happening. We're just returning true. So basically, we show profitability, the profitability section for every project. But on the right, we have the same function in the sale project bridge module. So as you can understand, we can also extend functions in the bridge modules. And here we actually use this field that we saw before, the allow billable field, to check whether we should show profitability. So now, with the sale project bridge module, we only show profitability in billable projects. But let's assume that now we're showing profitability. And we move on to line 14, where we call the get profitability items method in the project.project model. So let's see what this method does. Here it is. We have the get profitability items method in line 1 and 2. And as you can see, it only calls another method, which is the get items from account analytic line. It's al method. And you can see that method at the bottom. It doesn't really return anything. It returns a dictionary of revenues and costs. But as you can see, the data values are empty. So it basically returns nothing. And this is in the base project module, of course. But as with the show profitability function method, this can be extended. And for example, this is the same method, the get items from account analytic lines method, but this time in the project account module. So we're going to focus on this. And I know it's kind of big and we can't take it all together. So we're going to break it into steps and we're going to look at each step individually. So we begin by getting basically the analytic lines that are interesting for us, that are related to the project that we're looking for. So in the beginning, we're getting the domain from get domain account analytic line with no move lines, and this method is at the bottom. It returns a domain that looks basically that the account ID is the same as of the project, so it is analytic lines that are related to the project. It has no move lines, and it's not a manufacturing order. So we use this domain that we've found in line 3, in line 4, where we search through account analytic lines, and we save that in the AAL other search parameter. Now in line 8, we check whether this search actually yielded some results, because if it didn't, we can just again return that dictionary of costs and revenues with empty data. But if it did, we can continue in gathering all the costs, the revenues, and their currencies from the account analytic lines. So in the beginning, we create 2 dictionaries, one for the dictionary for amount per currency ID and one for the currencies. And then we create 2 lists for the cost IDs and the revenue IDs. Then we loop in line 18, we loop over all the account analytic lines. And we basically populate these dictionaries and these lists depending on whether the account analytic line concerns a cost, a revenue, and whether which currency it is, basically. So from that, as you can understand, we can have account analytic lines that are of different currencies, and that's a problem, right? Because it's kind of difficult to judge the profitability of a project if all the lines are of different currencies. So we want to standardize that, and that's what we do in the next part of the method. So in the beginning, we define 2 new variables, the total revenues and the total costs. And then what we do is we get all the currency IDs that we've taken from the account analytic lines, and then we get the rates for each of the currency IDs. Then we get the currency ID of the project, and then we loop over all the items in the dict amount per currency ID, so basically the amount per currency ID dictionary, and we add each cost or revenue to the total revenues and the total cost variables, but by checking the currency ID. So if the currency ID is the same as of the project, we don't do anything, we just add them to the total revenues and total costs, but if they're not, we compute the rate, and we basically change it to the company, to the project's currency before we add it to the total revenues and total costs. Then what we do is we receive the sequence for each invoice type, basically the ordering of all the items that are all the item types that are in the that should be in the profitability section. So we do that in line 41, yeah, in get profitability sequence per invoice type. And then we apply it on lines 42 and 48 by creating two new variables, the revenues and the costs. Then in line 55, we check whether the with action parameter that we passed in this method is true and whether the user has at least read-only rights to the projects and the accounts. If that's the case, we add we call the get action for profitability section method, which adds basically an action to the revenues and the costs dictionaries that we have defined, and this allows basically the users to click on items in the profitability section to have more information about those items. Finally, if everything has worked properly, which it should, we return all the data. We again have the revenues and cost dictionary, and then now, as you can see, the data is filled with the revenues and the costs. Now let's go back to the get panel data. Now that we have the profitability items in line 14, we can move on. In line 15, we have an if statement which checks whether there is a sequence for each invoice type and whether we have profitability items and whether we have revenues and costs in those profitability items. If we do, we sort the profitability items and we, depending on the sequence that we have. And then finally, in line 23 and 24, we add the profitability items and their labels by calling the get profitability labels method. We add them to the panel data that we return to the front end. And finally, in line 26, we return the panel data to the front end. Now, you'd think that we're done, but actually we're not. So there's more to this. And you'll probably remember the get profitability items method that we had from before that was calling the get items from account analytic lines that we were investigating. So this method, the get profitability items method, actually can also be extended in other modules, and it is. And so, for example, in the project HR expense module that we saw from before, it's extended and it adds expense data in your project's profitability section. So this is the method. We're not going to go through it, but it basically adds the expense data, as I said. And as I said, profitability method, the profitability feature also works with a lot of other bridge modules that add additional functionality to this feature. So, for example, the project MRP module adds costs related to manufacturing orders to the project profitability. The project purchase module adds costs that come from purchase orders. The sale project module adds revenues that come from sales orders. And the sale timesheet module adds revenues and costs that are related to user timesheets. So on the right, you can see kind of how this feature is set up across all the different bridge modules that are using it. The regular arrows with the regular pointed tip are explicit method calls, and the arrows with the hollow tip are basically inheritance calls. So as you can see, the feature from something small can actually grow quite a lot because of all the interactivity that we have. But also, as you saw from the methods that we investigated, it's all very simple, it's all very tractable, etc. Now, what's the final product? The final product is this. It's basically a rundown of all your costs and all your revenues for a project. As you can see, it has revenues and costs that are related to timesheets, materials sold and materials used in manufacturing orders, purchases, and expenses. It's basically a very helpful rundown for the project managers to look at the financial side of their project. Now, this is where we're going to be doing an intermission, but we're not, so skip that. And we're going to go into the planning application, my favorite application, kind of an interesting application. So if you don't know anything about it, it basically allows users to plan, track, and manage their resources shifts. And it's kind of organized around a Gantt chart that allows planning managers to view their upcoming operations. So another database schema. Again, not that complicated as the project modules, but still we're going to take it step by step. So we have first the planning slot model. So the planning slot basically represents the shifts, the planning shifts. They have fields that are typical, such as the name of the shift, its start and end daytime, whether its allocated hours, or Boolean fields such as the request to switch, whether the user has requested to switch this shift. And it also has relational fields to the other models, such as the resource ID, the role ID, the template ID, and the recurrency ID. Now the resource model, this was an already existing model. So as you can see, it's not a new model. The fields that are in bold are the newly added fields. So by design, from the get-go, it has like a resource name, the resource type, its calendar ID, fields like that. And we also add a color field, which is used for visual purposes in the Gantt view. And we also have the role IDs field, which points to different roles that the resource can take. Then the planning.slot.template model, it's basically planning templates, planning shift templates that the shifts can have, that you can give your shifts in during creating them. So they have a name field, they have a relational field pointing to the role for this specific shift, and they also have the temporal shift fields such as the start time, its duration, and the end time. Then we have the planning.role model. It's basically a model that represents roles that the resources can have. The model has a name field for the role's name. It has a color, again, for visual purposes, and it has a relational resources IDs field, which points to the resource records that actually have this role. Then we have the planning.recurrency model, which it's very similar to the project.task.recurrency model. It's basically a recurrency configuration that now your shifts can have. And again, it has a relational field to the slot IDs, which basically point to the slots that have this recurrency configuration. But it also has temporal fields such as the repeat interval, the repeat unit, the repeat until, or the repeat number. Finally, we have the planning.planning model. Now, as you can see from the diagram, it's kind of separated. We only use that when we share the planning with the resources. And it basically has fields that are used. So when the planning is shared, we fetch the appropriate shifts. So it has fields such as the start and the end daytime of the planning. And it also has Boolean fields, such as the include unassigned field, which basically shows whether we should show open shifts to each user. And it also has Boolean fields as the allow self unassign, which basically shows whether we should allow users to unassign from the shift that they just received. So again, as with before, the planning app has a lot of bridge modules that provide it with extra functionality. Here we can see some of them. We have the project forecast, which basically connects the planning app with the project application. We have the sale planning, module, which connects the sale app with the planning application. We have the planning contract, which adds the contracts application with the planning application. We have the planning holidays, which adds the time off application with the planning application. Planning HR skills, which adds skills to the planning application. And of course, we have many more. Wow. And now we have our second practical example. We have kind of blasted through this presentation. We have a lot of time. So we have our second practical example, which in this case is the auto plan button of the planning app. Now, what is the auto plan button? I hear you ask again. And in this case, the auto plan button is basically a button that you can find at the top of the planning application. And what it does when you click it is that it takes all your open shifts, look at your resources, their availability and their roles, and basically assigns the open shifts to your resources according to those specific fields. This auto plan button exists in the open shifts form view, so you can also auto plan one individual open shift. You don't have to do it for all of them all at once. So let's see how it works. A small remark before we do so. This feature is actually kind of big, and the implementation is kind of big as well. So we might have to skip some parts, and we will have to skip some parts. But it will make sense, and the slides are online in the pad. So if you want to go back, you can always do so and look at the code again. So it all begins in the front end once again. Now, once we click the button, it calls this auto plan method in the front end. And what this does, as you can see in line 3, it calls it does another ORM call, which calls the auto plan IDs method. Now, the model that we call this method from is given by the getRes model method. And we also pass a domain to the method as a parameter, which we get from the getDomain method call, I'm sorry. Now, what this returns, you can see at the bottom. So when we are in the Gantt view, as we saw, we get a temporal domain, basically a date range domain, which basically states which is the date range of the open shifts that we're about to plan. And when we are in the form view for one individual shift that we want to auto plan, it basically only gets the ID of the field, of the shift, I'm sorry. Now, let's look at the auto plan IDs method that we're calling from the front end. Now, as you can see, it's already kind of big. We're going to, again, take it step by step. Yeah, we're going to take it step by step and make it a little bit more tractable. So what we do firstly in the method is we do some assertions. We want to check whether we're calling the method from the right place. So we look at the context and we see whether we have a slot ID, if we have one individual shift that we're planning, or we have a start date time and an end date time, basically a date range, so we can plan multiple shifts. Then what we do is we get all the open shifts in that period. Now, we do this by doing the read group operation that you can see in line 8. This basically works as an SQL query. In the first part, we have the where clause, so we give the view domain, and we also say that we want our resource ID to be false. Basically, we want this to be an open shift. Then the second part is the group by, and we don't really want to group by anything, so we leave it empty. And then we state the fields that we want to return. So in this case, we want to return the ID for the open shift variable, the start date time for the min start, and the end date time for the max end. And as you can see, we also have some aggregate function. In the start date time and the end date time, we have the min and the max for the min start and the max end. And for the ID, we have the record set. We're taking all the shifts, basically. We're not aggregating anything. So once we do this read group, we should have all the open shifts. Now, in line 16, we check whether we have open shifts, because if we're not, there's nothing to plan, so we just return an empty list. But if we do, we continue. And what we do next is we get the user time zone and basically apply it to the min start and the max end, which are in UTC currently. So up next, what we want to do is we want to get all the resources that we can assign to all the open shifts. So how we do that is we basically get all the roles that we can find from the open shifts, and we do a search to the resource.resource model, in which we get all the resources that have a calendar, which basically means that they have work hours, they have a work calendar. And we also get the resources that either their default role or one of their roles is related to the roles from the open shifts. So basically, we're getting all the resources that have calendars, and it would make sense to plan them for these open shifts, given their role. Then we create two dictionaries of lists, the resource IDs per role ID and the resource IDs per default role ID. And we're differentiating between the role and the default role because we are kind of prioritizing the default role. And then we go over all the resources and basically populate these two dictionaries. Finally, in line 42, we call the getValidWorkIntervals method from the resources method. And this basically should return the work intervals for each specific resource. And these you can think as a list of tuples with the one value being when the resource starts working, and the second value being when the resources stop working. So let's then, now that we have all the resources and now that we have all the open shifts, let's now get all the shifts that belong to these resources. We do that by changing the min start and the max end variables, and we basically add one day to the max end. And then basically we search through all the planning slots that belong to the resources that we have already gathered, and they are between the min start and max end. And from this search, we only get the start date time, the end date time, the resource, and the allocated hours of the shifts, and we save it in the same day's shifts variable in line 48. Then in line 54, we call the shift to records to timeline per resource ID method, and we pass the same day's shift as a parameter. And what this method does is basically it returns a timeline of each resource, basically what they have to do at each point in the timeline. So we're not going to look through this method, even though it's kind of a crucial one, but we can see kind of an example of what it looks like, what its return should look like. So as you can see, it's kind of a timeline. It's a list of tuples, and one of the values is basically a daytime object. So as you can see, the first one is 9th of November 23 at 8, and on the second value is basically a workload percentage. So in this case, this example, basically we have two shifts, one from 8 to 10 and one from 10 to 12. And the allocated hours for each shift is 2 hours, basically 100% of that time range. So yeah, in the first tuple, we have at 8, 100% of the resources workload should be at a shift, and then that goes to 0 at 10 because the shift ends then. But then again at 10, it goes back to 1 because the resource does the second shift, and then at 12 it goes back to 0 again because the second shift has ended. Now, the final part of the autoplan IDs method is that we basically call the find resource method through a filtered operation. Now, what the autoplan IDs method does is that it returns, first of all, it finds resources for the open shift, but it also returns the open shifts that have been properly planned. So that's why we use the filtered operations here. So now let's look into the find resource method. So this is the method. Now that's a little bit smaller, so we can just focus on this. And so what we do is first we create a shift. We create an intervals object called shift intervals for basically the shift that we're trying to find the resource for. So because we're using the filtered operation, we call the find resource method for each shift. So we create those intervals, and then we go over the resource IDs per default role and then the resource IDs per role ID. We gather the resources for each of these dictionaries. We shuffle them because we don't want to always give the shift to the first available resource. And then we go over all the resources one by one. And what we do is we get the union of the shift intervals with the work calendar of the resource. And that should basically return the union. So if there is no union, if the result of this is nothing, that means that the resource doesn't work at the time that the shift is planned. So if that's the case, then we continue. But if not, we continue, and I mean we call the continue, let's say, and we just skip this resource. But if there is, the split shift intervals is populated with something, then we continue with the execution. Then we call the get new timeline if fits in method. Which basically is another method that we're not going to look at, but we pass it the split shift intervals that we've created. We pass it the hours per day that the resource should work from, and we get that from the calendar of the resource. And we also pass the timeline of the resource that we have computed from before. And so we're not going to look at it, but I want again to kind of go and see how the return of this method should look like. So as you can see, we have the same timeline from before, but now we're adding a new shift, and it's a shift from 9 to 10, and it's a 1-hour shift again. So as you can see, we have a new entry in our tuples for 9 a.m., which now increases the workload percentage from 1 to 2. And that basically means that the shift doesn't fit in this schedule, in this timeline. So if that's the case, then we return false. Also, this method checks for the work hours that the resource is working, and it checks whether the planned work hours with the additional shift would be more than the work hours that the resource should work. And if that's the case, then it also returns false. But if none of these are, if none of this is the case, then we just return the proper timeline. Now back to the find resource method. If we've gotten a timeline, or if we just return false, we save that to the timeline variable. And in line 22, we check that. We check whether we have a timeline or whether it's false. So if we have a timeline, we give the resource to the shift. So we basically plan the shift. We have given it a resource. And if we don't have a timeline, wait, sorry. We're still in the we have a timeline case. So we do that. Then we update the timeline for that resource. So if we have multiple shifts that we're planning, in the next shift that is planned, we have the updated timeline. And then we just return true. So we can, in the auto-plan IDs method, when we return from the filtering, we also return that planned shift. Now, if we don't have a timeline, what we do is we just continue to the next resource. And we do that for all the resources and for all the dictionaries, whether it's a default role or a regular role. And if we don't find anything, we just return false, which means that we haven't really planned the shift. And that's pretty much it. That's how it works. And that is the end of the presentation. I kind of rushed through it. I know I didn't leave a lot of room for breathing. But yeah, we didn't have a lot of time, so I really wanted to have some questions. I hope you do. And yeah, if we have any questions, that'd be great.
Hello.
Hello.
Thank you for this presentation.
Oh, thank you for having me.
So for the moment, we have no questions, so
All
don't
right.
hesitate. Maybe we can share a link again in case someone didn't have a chance
let's do share
to...
the link. You're completely correct. Yeah, I'm sorry, everybody. I would have like QR codes in both the intermission and the end slide, but for some reason my QR code was not working today. So here's the link. Again, you can just go to pad.odoo.com, and then after this /p/ and then you can go odoo_oxp_services_tech_door. A lot of underscores. But yeah, if you don't have any questions right now, or if something might pop up later, or if you just want to have like a discussion over these things and you want to dig deeper into the code, I'm going to be at the technical booth all day tomorrow. So you can come and we can talk about these things.
We have a few more people connected, so I can see 2 questions have been
That's
typed.
great. That's
We're
great.
going to wait a bit. Where we can find documentation on this?
Sorry, can I?
Yes, the first question is where we can find documentation on this.
Where you can find documentation of this. So our documentation mostly covers the JavaScript and the ORM framework. So you can't really find documentation in this. But what you can do is just, if you have access to the code and the timesheets and the project applications, you can find them in our GitHub. Because our community versions, the planning, unfortunately, whatever, it's in the enterprise version, so you have to have access to that. But yeah, currently there's no documentation for this. But in the code, we have a lot of documentation inside of it. So a lot of comments, a lot of explanation of how these things work. So if you do have access to the code, they're actually very easy to track them down and see how they work.
There is a small compliment that's being typed. You're a great developer. Have you ever considered working for a human resource team?
Wow. I mean, I'm part of the recruitment team. If that counts, I do some interviews. If anybody wants to join Odoo, they might have me as an interviewer. That's kind of nice.
Well, we have a bit more questions, but I'm afraid due to the technical issues we had at the beginning and
Right.
lack of time now,
Right.
don't hesitate to come to the booth to ask questions in private. And I hope you enjoyed it. Thank you.
Thank you very much, everybody.